Hello, today we'll talk about expected value, a concept very commonly found in the world of economics and finance. We'll start by taking a look at the formula and then playing a simple guessing game, and we'll finish with a more serious investment problem. Let's start with the formula. We have the expected value for a random variable x, which equals to the sum of the probability of a particular outcome for x multiplied by the numeric value of that outcome. To make matters more simple, let's take a look at a coin toss. We'll first assign the value to heads and tails, and heads will be -1, whereas tails are going to be 1. So for a fair coin toss, the probabilities are equal. They are 1/2. And the expected value for a coin toss gives us 1/2 multiplied by 1 plus 1/2 multiplied by -1, or 0. That tells us that on average, as we keep flipping the coin, we're going to get about an equal amount of heads and an equal amount of tails, which will give us the net value of 0. Let's move on to a more interesting example. Let's say you have a slightly obnoxious classmate who wants to play a game with you, and he offers you easy money. And he says, all right, I have a number from 1 to 25 that's generated by a computer program, and you have to guess, and if you do, you win $100. However, if you don't, he's going to take $5 from you for each attempt. So, what do you say to your friend? Are you going to play? How many times will you play? And what do you expect to get? Let's take a look. We'll calculate the expected value for each game that you're going to play with your friend. And what it gives us is this. You have a 1 over 25 probability of making $100 or guessing the number, and 24 out of 25 times where you don't guess the number and you lose $5. That gives us 0.04 multiplied by 100 minus 0.96 multiplied by 5. So the expected value for every game that you play with your friend is going to be -80 cents. Wait, so what does that mean? How come if I play, I'm going to make -80 cents if I'm going to lose $5 or make $100? And that's the thing you have to understand about the expected value. It works the more you play the game. So it averages out to 80 cents per game the more games you play. Of course, for the first game, you might win $100 on your first try. But then as you keep playing, you're also going to lose. You cannot expect to keep winning $100 every time. So, and that's why, let's say if you play 25 games, on average, you would lose $20. So you guessed right one time. On average, you'll guess one time out of 25, and that will make you $100, but you're still going to lose $120 just because the other 24 times you're not making anything. You're just bleeding money. So yes, is it easy money? It is. However, not for you, for your friend. So definitely do not play that game with him. Moving on to the investment problem. Let's imagine for a second that we have $100,000 that we want to invest into 10 promising tech startups. We do our research, and what we learn that 90% of startups never make it to the IPO. They never go public, and their founders lose money. The other 8% will go public with an average return of 400%. And 2% become the moonshots. They are the Facebooks and the Googles that go up incredibly high and make your investment really pay off. So you can expect to make about 3,000% in returns. So question is, what is the expected value of your investment? If you invest $10,000, 10 times? Well, let's find out. So the expected value for our investment is going to equal to $40,000, which is the 400% returns multiplied by 0.08 plus $300,000 multiplied by 0.02. And of course, we subtract from that the $10,000 we lose every time our company crashes and burns, which is unfortunately 90% of the cases. And what do we get as our expected value? $200 per one investment, which gives us $2,000 for the 10 companies that we invest into. And this, ladies and gentlemen, is very underwhelming. So why does that happen? For that, we need to take a look at the way returns are distributed among startups. And it doesn't follow a normal distribution, as you can see. It in fact follows the long tail distribution, where the slimmest percentage of the startups get all of the returns. They become the Googles and the Facebooks, while the rest of the companies, well, they just kind of get by. At least they went public, at least they're still there, but they don't make the crazy money. So as an investor, that's why you're always trying to seek out those diamonds in the rough. You're trying to find the next big thing. And hopefully this payoff will really reward you for all of the other 90% of the startups that crashed and burned, right? So it is a high risk, high reward game. Thank you very much for watching. Hopefully this video was somewhat useful to you. And if you did enjoy it, please let us know in the comments. Your feedback means the world to us. And stay tuned for more.